Ever since humans appeared on Earth, we interact with things. As technologies improve, we created new ways of interaction and reshape our lifestyle. Now, millions of people work very hard to design and develop user-friendly interactive products. But people's understandings about interaction are not always the same. Sometimes vastly different that may cause serious communication problems. For example, many designers tend to think touch gestures like drag, flick, and swipe would have some universal standards that developers can just use in their code, while developers claim that they can only obtain raw data like position and trace of touch points from the device. Gestures are then calculated based on those raw data. Ambiguous words like drag or flick may sometimes be confusing, so designers should describe their interaction ideas in detail carefully. This gap of understanding shows how people think differently about the complexity of interactions. Is it simple phrases, complicated codes, or something else? Different representations have different pros and cons. Like in music, numbered notation, staff, and audiograph can all be used to describe the sound, but they represent different levels of complexity. Staff becomes the dominant language of music because it can cover a broader range than numbered notation and isn't like audiograph, which contains redundant physical patterns to music. Since 1300 years ago, Occam's razor guides us to shave away unnecessary parts, keeping things as simple as possible. Later, Einstein reminds us not to make things simpler than what they actually are, otherwise an essential part of it would be lost. Bill Moggridge, who proposed interaction design as a discipline, suggested that we also need a language unique to interactive technology. Such language can help people understand and communicate the actual complexity of interactions. Established design systems like material design and fluent design are not, in a strict sense, real languages. They are guidelines to keep third-party applications consistent on a particular platform. A language is a notation system. One essential character of a real language is the infinite use of finite media, which allows people to create infinite new expressions with limited components. Developing a language is very complex because a language is more than its alphabet and grammar. It also represents a specific perspective of looking at things. Mastering a new language can profoundly reshape the way we think and behave. So, before we develop the unique language of interactive technology, it is very important to examine our fundamental assumptions about it. Normally, we consider interaction as input and output between user and device. Many theories, methods, and tools are developed based on this idea. Despite many useful insights, this view inevitably relies too much on devices. But devices change very quickly as technologies improve. This makes it difficult to apply the lessons learned from one device to another. To change this, we need to change our perspective. But changing perspective can be challenging. Like Neo in the Matrix can look at a spoon from different angles. But in order to bend it only by his will, he must realize there is no spoon. It is not a spoon that is bending, but his own mind. Led by this idea, we spent years of research and practice to develop our perspective and interaction design language. Instead of thinking about input and output, we consider interactions as people's ability to control various objects, namely control force, like Thor's control on his magical hammer. But our control force does not rely on magic, it comes from technology. Different devices provide different types of control force, which allow people to control different hammers, such as a photo, an icon, a list, or any items you need. With control force, people are able to accomplish various tasks. But control force is a very abstract idea and cannot be directly used in design practice, so we developed various concepts and notations to thoroughly describe all aspects and details of the control force. Along with explaining various interactions, this language of interaction design can be helpful in three ways. First, Designers can use this language to describe and organize the structure and nuances of interaction in detail. Interaction ideas can be thoroughly communicated and discussed among designers and developers. Second, because this language focuses on the relation between people and the object they want to control, devices become secondary in the conversation. As a result, seem-to-be different devices may have a very similar underlying structure of interaction. We can learn from interactions on one device and apply them to various new devices. And last, because of its linguistic character, this notation system encourages designers to try out new combination of different components, which leads to new interaction styles. This language of interaction design is not meant to replace, but enhance existing methods of designing interactions. Together, we can have a richer understanding of how to design a better interactive product. More information about the theory and the practice of this language can be found at IxDlanguage.org. We are very excited to see what new interaction designs you can create through this language.